Hi, Assalamualaikum and a very good morning. Now we are in chapter 4, which is Introduction to Organic Chemistry. We're going to focus on the subtopic of 4.2, which is Functional Group and Homologous Series. So in this video, we're going to learn on how to define and identify functional group, which is represented by Fg. Also, we're going to learn on how to classify organic compound according to their functional group. For example, if we are having a functional group of hydroxy, which is represented by OH here, it basically means that the class of the organic compound going to be alcohol. Alright, and for the next part, we're going to learn about the definition of the homologous series and also explain the general characteristic of the homologous series. So every homologous series will be represented by a general formula. For example, alkene will have a general formula of C and H2N plus 2. And for each homologs, they will be having the same functional group and react in a similar way chemically. Also, when there is an increase in the number of carbon atoms, there will be also changes in the physical properties. And usually, the successive member of the series will be differ by CH2 chain or by the increase of 14 gram per mole. For example, from methane, CH4, it will be increased to ethane, which is C2H6. Alright, so there will be an increase of CH2 group or 14 gram per mole. Alright, so without any further ado, let us start. So, functional group is basically an atom or a group of atoms in an organic molecule which characterize the molecule and determine on how the molecule reacts. So, the importance of the functional group basically help us to classify organic compounds which are divided into different classes. As mentioned, if you are having a hydroxy group, it can be help to classify the compound as alcohol. Also, it helps us to do the naming. For example, if you are having a carbon-carbon double bond, which is the functional group here, you know that it is a class of alkene. So, by knowing it is an alkene, it will help you to do the naming. For example, butene. Also, by knowing the functional group, we will know that what kind of reaction or chemical reaction that will be taking place in the organic compound. So, generally, by looking at the functional group in an organic compound, we can determine the class of the compound it belongs to. So, let's look into the example here, which is cyclohexane and propane. So, for the cyclohexane, it will be you will be having a structure of like this, and for propane, you will be having an expanded structure of like this. So, as what you can see here, for cyclohexane and propane, it only consists of carbon and hydrogen. So there will be no functional group present here. So when there is no functional group other than carbon and hydrogen, means that the class of the compound here is an alkane. Alright. Meanwhile, for the next example, which is cyclohexane, which is written as here. So this is the skeletal structure of cyclohexane. And here is a propene because propene has 3 carbon, right? So it's going to be 1, 2, and 3. And it has 1 double bond. Okay, so the functional group here, which is something that is differ from CH single bond, is the C double bond here. So we got 1 here and we got 1 here. So we can say that the functional group is C double bond C. Or we can say that carbon-carbon double bond. So hence we can say that the class of the compound going to be alkene. Next is propane. Okay, so for propane, we got the C, we have 3 carbon, but one of the bond here is a triple bond. So this is something that is distinctive, lain daripada yang lain. So we can say that the functional group here is a carbon-carbon triple bond. Hence, we can say that the class of the compound going to be alkyne. So, as what you can see, by knowing the functional group, we can determine the class of the compound. Moving on, we will have 1-chloropropane. So 1-chloropropane is basically almost similar to propane, which is C3H8. However, one of the hydrogen is changes to chlorine. So you're going to be C3H7Cl. Alright, so the drawing going to be similar to alkane or propane, but one of the hydrogen going to be changes to chlorine here. Okay, so you can change here or here because it refers to one, so it needs to be at the initial. Alright, so in this case the chlorine is written here, which is the carbon number 1. Okay, and that is why the name is 1-chloropropane. So the one that is distinctive here is the chlorine atom here. So you can say that the functional group here is halogen, which consists of chlorine, bromine, iodine, or fluorine. In this case, the halogen here is chlorine. Alright, but it is sufficient for you to just write it as halogen. And the class of the compound is basically haloalkane. Alright, if propane is an alkene, however, when there is a halogen, it's gonna be haloalkane. Moving on, we have propan-1-ol, which is an alcohol. So propanol is basically the same as alkane, but one of the hydrogen here is changes to OH. So that is why we have OH here. So OH here means that it is having a hydroxyl group as the functional group. So when there is an OH group here, it basically means that the class of the compound to be alcohol. Alright, now we have OH, which seems like to be an hydroxy, but now it is attached to the benzene ring. So this benzene ring can also be represented to be a circle in the middle, which basically means that the electron or double bond can be delocalized in the ring. So either way, if you write it this way or this way, both are correct. It just means that the delocalization of electron are happening. Alright, so for this case, the functional group not gonna be hydroxy. Okay, not hydroxy. So hydroxy is wrong because hydroxy is for aliphatic or a single carbon change. So here is hydroxy. However, when the OH is being attached to the benzene ring, we have to circle this all. Means that it is a new functional group, which is phenol. So you have to circle it all. And the class of the compound coincidentally have the same name as the functional group, which is phenol. So the functional group is phenol, which is the whole thing, and the class of the compound is phenol as well. Now, moving on, now we have a propanoic acid. Okay, so propanoic acid can be drawn to be something like this. So propane, propa, basically means that it has 3 carbon. So 1, 2, 3. And oic acid means that it has a functionality of C double bond or OH here. Okay, so the functional group here basically means that it has a carboxyl group. And the carboxyl groups basically helps to class the compound to be carboxylic acid. Okay, and specifically it is known as propanoic acid because it has 3 carbon. Moving on, now we have the ethyl attenuate, which is the class of the compound to be an ester. So the functional group which is distinctive here is the C double bond O here. Okay, so we can take it all here and we can say that it is a Carboalkoxy group, which basically means that it is an ester, which is an esterification process between alcohol and the carboxylic acid. Okay, so the functional group here, you have to label it up to the carbon here. Okay. Now we have another type which is the anhydride. So what is very distinctive yang sangat berbeza dekat sini adalah C double bond O, C double bond here, O here. So when you see C double bond O, C double bond O, it means that it is an anhydride functional group. So the class of the compound going to be anhydride as well. Now, what is distinctive here is the COC here. Okay, so this refers to the alkoxy group on the class of the compound going to be ether. So in this case, it's going to be diethyl ether. Okay, C2H5, which is here, C2H5, and then oxygen in the middle here, and then we have another C2H5 here. All right. Now moving on, we're now having a propanal, which is C2H5COH. All right. So it can also be written as CH3, CH2, which is the CH3 here refer to CH3, CH2, C double bond OH. So what is distinctive here is the C double bond O attached with hydrogen here. So everything here is the functional group. Okay, so this refers to the carbonyl group. But for this case, we are referring to propanal, means that C double bond O here attached with hydrogen. Okay, so really need to be careful. For propanal, C double bond O, one of the carbon here will be attaching with the hydrogen. So it is called as carbonyl group, but refers to aldehyde. Okay, so when there is hydrogen attached to it, it is an aldehyde. Meanwhile, for this case, when the C double bond O, both of them are attached with carbon and carbon here, it basically means that it is a ketone. Okay, it is still a carbonyl group, but the attachment here is carbon and carbon. Just now, one of it is carbon, the other one is hydrogen. Alright, so if both of them are carbon, means that it is a ketone. Okay, and here, as what you can see, CH3 referred to here, CO, the carbonyl group here, and another CH3 is at the back here. Okay, now we have another functional group which is C double bond OCl. So here refer to acyl chloride, and the class of the compound is the same, which is acyl chloride as well. Okay, so it means that the C double bond O, but now it refers to chlorine, then we can refer it as acyl chloride. For this case, when the C double bond O attach with the nitrogen with NH2 here, okay, so you can say that it is a carboxyamide. So it is an amide. Meanwhile, if there is no C double bond O, but it just the NH2 here stand alone, you can say that it is a amino group. So for the amino group, it is when the C and are attached together and it has a hydrogen attached to it. So it is an amino group, and it is the class of the compound going to be amine. Meanwhile, for here, the most distinctive feature here is C triple bond N. So this refers to the cyano group, where the class of the compound going to be nitrile. Okay. Now, the structure here refers to the methyl benzene. So here is the methyl group. Okay, this here is the methyl group. Meanwhile, here refers to a benzene. But the other name of this structure is also known as toluene, or we can write it as C6H5CH3 because it has 1, 2, 3, 4, 5, 6. So we have C6H5 because here containing one hydrogen on each point. And then it is attached with another methyl group, which is CH3. So you can write it as a double bond at 3 different sides, or you can write it in terms of circle. Doesn't matter. Alright, so both are accepted. And as what you can see here, the functional group here is the benzene ring, or as the phenyl group. So the class of the compound going to be an aromatic or arene. So both are accepted. Now let us do the example here. So we have to determine the functional group and class of the compound. So in this case, we can see that C double bond here is very different or very distinctive. So C double bond here, and you can see that C double bond here attached to another carbon and attached to another carbon. So the functional group here is carbonyl. Meanwhile, the class here gonna be ketone because it attached to the carbon. For this side, we can see that C double bond O and C double bond OH here. So the functional group gonna be a carboxyl group, and the class of the compound gonna be carboxylic acid. Meanwhile here, we know that we have the CN here. So the functional group here gonna be cyano, and our class of the compound gonna be nitrile. Okay, and for this one, you can see that here gonna be the functional group. Okay, and where here refers to the alkoxy group, or the class of the compound gonna be ether. Meanwhile, for E, we have a different attachment here, which is NH2. So this refers to the functional group of amino, or the class of the compound here refers to amine. Meanwhile, here the benzene ring gonna be the functional group, and the class of the compound is the aromatic compound. Now we're going to do example 2, which is determine the class of the compound. So we can determine the class of the compound according to the functional group here. So here you can see that C double bond O attached with another C, attached with another C. So you know that the class of the compound going to be a ketone. Okay, so here going to be a ketone, and here got triple bond here, which refers to a alkyne. Meanwhile, here refers to aldehyde because C double bond O, one of the attachment is hydrogen. Okay, and here is carbon. So the difference between ketone and aldehyde is one of the attachment is hydrogen. So the class of the compound here going to be aldehyde. Meanwhile, here it has an OH group which refers to hydroxy functional group. However, the class of the compound is alcohol. Okay, so there is a difference between functional group and the class of the compound. So be really careful of that. Now, we're going to do example number 3, where we have to identify the functional group in the following molecule. So here we can see that this is one functional group. So this refers to the carboxyl group. And then we have another here, which is C double bond O, CO, C double bond O, which refers to the anhydride. And then we can find another here, which is refers to OH here, which is hydroxyl group. And here C double bond O NH2, which refers to the carboxyamide. And we have NH2 here without C double bond O, so we know that number 5 here is an amino group. And then we have C double bond here, so we can say that it's a carbon-carbon double bond. So the functional group is the carbon-carbon double bond. However, the class gonna be alkene. Okay, so the question asks for functional group, so do not confuse or change them. Okay, and lastly we have C double bond O or C here. So for number 7, it is a Carboalkoxy group. Alright, now we go into the homologous series. So homologous series is basically a series of compounds which contain the same functional group, and each member differ from the next member by a constant of CH2 unit. So as what you can see here, methane, ethane, propane, and butane is a homologous series of alkane, and it differs from one another by a different unit of CH2. So here also differ by CH2. So in C increased by 1, hydrogen increased by 2. So the members of the same homologous series are called homologs. So one of the characteristic of the homologous series is it has a general formula. For example, alkene, it will have a general formula of CnH2n plus 2. And we can see that when there is an increase in the number of carbon, the physical properties will be changes as well. Okay, so for the first four here, it may exist as gas. But when you start going to pentane, then it will be going into liquid. Alright, so when there's increase in the CH2 unit, the physical properties will be changes as well. However, because it contains of the same functional group, the chemical properties is still maintained. Okay, so functional group, chemical properties still maintained because of the same reactivity, but however, physical properties will be changes because there is an increase of the CH2 unit. And because of the same chemical properties, it can be prepared by the similar chemical method as well. And here are the summaries of what I have talked about, and same goes to this slide here. Okay, I think that's all for today's video. See you again some other time. Bye!